Hello, this is Mr. McGovern, and this is the 7th video in the Projectile Motion series where I am looking at an NCEA problem. And the problem I've got here is the 2019 mechanics paper, question 1A, B, and then D as well. So here we have a girl playing hockey, and she wants to hit it to her friend Josie, who's some distance away. So she hits the ball at a velocity of 22 meters a second with an angle of 30 degrees, shown in the picture. So the first one says, show the initial vertical velocity of the ball is 11 meters a second. So regardless of what they've asked us, in a projectile motion problem, you want to separate the idea into horizontal and vertical bits. Okay, they're components. And this being the first question in the exam, they're kind of stepping us through that and asking us to do that anyway, so they're helping us out a bit. So here is the same diagram there, but what I've done is I've put on the horizontal velocity as the bottom of the triangle. Now instead of labeling a horizontal velocity, remember we use x for horizontal, so it's Vx, and the vertical velocity is Vy. Now they've asked us to work out the vertical velocity, so I like to write down my SOHCAHTOA, so I remember what I'm dealing with here. Vy is opposite, and the 22 that I've got as well is hypotenuse. So opposite and hypotenuse is SOA, sine. So I'm going to write my sine equation out with my values and rearrange that. 22 times sine 30 will give me my vertical velocity, or Vy. And 11 meters a second, I check with theirs. Yes, that's right. Therefore, got my achieved. Second question saying, describe and explain the motion of the ball. You should refer to any forces acting on it as it moves through the air. You may include a diagram. So I would suggest you draw a diagram. In fact, the way I do these kind of situations is I just draw the diagram, and then in my explanation I explain what I've drawn and why it's the case. So my diagram is a poorly drawn projectile path, and I'm going to do write down that I know projectile motion, because this is how we deal with it. It's described in horizontal and vertical motion separately. And here's a motion map for my horizontal motion. It goes along at a steady speed, so I'm going to write that down after I draw my diagram. The horizontal motion's at a constant speed. And then why? Well, the reason we know anything goes at a constant speed is there's no unbalanced forces in that direction, in the horizontal direction. The ball goes up and down. It has a vertical direction as well. And on the way up it slows, so it has acceleration pointing downwards. And then once it reaches the top and then it starts coming down again, it speeds up. And so the acceleration's still pointing downwards. So the vertical motion changes, or its velocity changes, right? It has acceleration. And the reason why this is because gravity is an unbalanced force that points down in the vertical direction. And you can see because that's the way the acceleration is all the time. So I find these description or explain questions really easy once I've drawn the diagram, all the diagrams that I know how to do, and then I just explain them. So that was worth a merit. Okay, D is saying that Josie's 44 meters away from Nicole when she passed it. Will the ball reach Josie before it bounces? And justify your answer using a calculation. So as always, I want to split this up into components, my vertical and my horizontal. I already did my vertical beforehand, and so now my horizontal is my Vx, and that's the adjacent in that triangle, so I'm going to use cos, rearrange it, and I end up getting 19.05 meters a second for the horizontal velocity. The second thing I do once I've got that is draw my table. Separate out a horizontal and vertical so I can clearly see they're separate. Draw yourself a table. So my horizontal motion, I also like to draw that it's constant velocity. It reminds me that I'm only using a constant velocity equation. My vertical motion undergoes acceleration, so I've got to use an acceleration equation for that. So what values do I know? So from before, my horizontal velocity that I worked out with my components was 19. I don't know how long it's in the air for. I don't know what horizontal distance it goes. But that's what I want to end up finding out, how far it goes. Josie's 44 meters away, but I'm not sure if the ball goes 44 meters, so I can't just put that in. The vertical motion goes up, and acceleration is down. So if I call up my positive direction, then my acceleration has a negative value because it's pointing in the negative direction according to my motion map. My initial vertical velocity that I worked out using my components is positive because it's pointing in the positive direction that I've chosen. Then, little trick that we did in the last video is I say, what time does it take to get to the top of the motion? At the top of the motion, the vertical velocity is 0 just for an instant. So that's just a little bit of extra information I've got. I don't know how much time that takes to get to the top, and I don't know the distance to the top, and I actually don't care at the moment the distance, the height it goes. So now I've got 4 bits of information, or 3 bits of information on the vertical motion side, the acceleration, initial velocity, final velocity, and I want to find the time it takes to the top. So those 4 bits of information can be used with this acceleration equation. And I write it down, put my values in with the positives and negatives. Remember, acceleration of gravity in this case is negative. Do some rearranging. When I move the 11 onto the left side, it becomes negative. The 2 negatives cancel out, and I get time to the top is 1.12 seconds. So I can put that in my table now. But I don't want time to the top. I actually want the total time. So I've worked out half of the time. The total time is double that. So I just do double that, and that's what I've written in my horizontal side. The time it's in the air for is 2.24 seconds. Now I've got 2 bits of information from the horizontal side. I can now use, because it's going at a constant velocity in the horizontal direction, I can use a constant velocity equation. The distance is just the horizontal speed, which is 19. I worked that out much earlier. And my total time it's in the air, 2.24. Multiply them together, I get 42.6, which is not the 44. Josie's 44, so it bounces just before her. Now to get this one, it says, will it reach Josie? I don't just need to do a calculation, I need to write a sentence. And so I can write down, it bounces before reaching Josie. And that was an excellence problem.